Hello, everyone, and welcome to the Esri GeoDev webinar series. This webinar is a continuation of the series we created in the hopes of engaging in developer-related topics and discussions in between Dev Summits. We have our next Developer Summit coming up in Berlin, November 6th through 8th, and we have a lot of new topics, advanced features, and additional functionality to share with you over the next coming months. So be sure to stay connected with us through our GeoDev webinar series page on go.esri.com/geodev or any of our social media accounts at Esri GeoDev. We would love to have conversations like these taking place throughout the year so that when we do meet at one of these Dev Summit conferences, it will be as though we never stopped. We hope you get as much or more out of this webinar than you anticipated. Now we would like to introduce you to today's webinar, Performing Analysis with the ArcGIS API for Python. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something that looks like this on your own computer desktop in the upper right corner, and you're listening in using your computer speaker system by default. But if you would prefer to join over the phone, just select Use Telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. I would now like to introduce Andrew Chepkowski, Senior Software Developer on the Enterprise team at Esri. Andrew, let's get started, shall we?
Thanks, Amy. So thank you everybody for joining, and today we're going to talk about performing analysis with the ArcGIS API for Python. A little about me before we get started is that I've been a developer at Esri for over 11 years, and I'm a senior software developer on the ArcGIS API for Python, which we're going to talk about, and the enterprise team. Also, in my personal time, I'm a big open source advocate, and I work on a lot of projects. Some of them I've included PyGeoPackage. Some of you might be familiar with ArcRest, which was mainly Python 2.7, and Hermes, which is a metadata manager for feature classes. I can be reached at achepkowski@esri.com for any questions, or on Twitter at achepkowski. So let's dive right into it. So we began about talking about what is the ArcGIS API for Python. Some of you may know and some of you may not. And what it is, it's really a Python library that consists of a bunch of modules and submodules to get things done working with your WebGIS. WebGIS is just a fancy way of saying that it's powered by your enterprise, which can be considered ArcGIS Online or Portal. And it complements ArcPy. So you can do all your desktop operations in ArcPy, but then you can also do things leveraging the WebGIS power, the distributed power. So let's take a look about what the API can do for you. And where we're going to begin is we're going to begin with DevOps. We're going to look at a bunch of roles, and the first one is administrators and DevOps. And the Python API, or the ArcGIS API for Python, for these individuals allows them to manage their sites, their servers, users, the various roles that exist, and groups. The next role you can consider would be content publishers. And these are individuals who are going to take information and put it out there as hosted feature services layers and other information. Maybe it's imagery, they keep track of tile cache, things like that. And then we have our analysts. And this is what we're here to talk about mainly. But these are individuals that work with imagery, hosted feature service layers. You could consider yourself a data scientist. And what we're going to use and we're going to leverage is Raster Analytics and feature analytics to derive new informational products. And then we have our power users and developers who basically span this whole platform. And together, all these individuals, and with using the Python API, sort of develop this Pythonic representation of our GIS. So let's take a look at the GIS class and the GIS module itself. We're going to use the GIS module to manage, maintain, and control and modify our GIS. It's going to basically allow us to manage our web presence. It's going to do a bunch of things for us that are really helpful. One of them is handle authentication, It's going to help us find and use content. We're going to be able to, if we're administrators, access the administrative side of our enterprise, so we can go and drill down and refine each setting the way we need to. And then we're also going to use it to perform analysis, especially for secure services. Let's take a look at a demo of how we can use this GIS class in order to get it done, because if we don't understand how to use the GIS object, everything else is sort of moot, because we can't, if you don't know how to connect and how to get access your WebGIS, you won't be able to get anything done. So what I have here is I have a Jupyter notebook, and we're going to go through this, and we're going to go through some basics. And with our content, we're going to look at, with our GIS basics, I mentioned before, it handles our authentication. It's good for searching and using content, and we're also going to be able to map information. And it's going to start with an import. So we're going to say from ArcGIS.gis, import GIS. And then we're going to create a variable, GIS, and we're going to create our class, capital GIS. And what this is going to do is this is going to connect anonymously to ArcGIS Online. If we provided a URL in the GIS and no credentials, it would anonymously connect to a portal. And it supports multiple authentication methods. Some of them listed are OAuth 2, PKI, IWA, for example, and named user. And here's an example of accessing named user. So here we're going to create our GIS class and provide a username. In this case, it's webinar user. Because we didn't put in a password and it's detected that we have named user login, it's going to prompt us for a password. Once the password's entered incorrectly, we can see who we're logged in as by doing gisuser.me. Now, there's times when you don't want to provide your credentials, and we can store our credentials using the operating system's credential store. And this is really neat, at least I think so. So we're going to use the getPath module to secretly enter in our password, like we did here. And we're going to create a new GIS class. And this time we're going to pass in that same username and the password that we stored secretly, along with the profile. And the profile name is going to take those credentials that we passed in here and store them in that operating system credential store. So now every time we want to use the webinar user, all we have to do is refer to the profile by that name. And we can do that right here. So we can say, we're going to delete this existing GIS object and create a new one. But instead of passing in a username and password, we're just going to use a webinar. And the power of doing this is that it prevents us from sharing credentials while sharing workflows so we can get things done. Now that we're in our GIS, we now have an entry into our WebGIS. We can access, add, and publish content now. We can manage, modify, and control our server, so if you're in that administrator role, and it helps us build our overall digital community. So now that we've logged in, let's look at a way of finding information. Here's an example where we're going to use the GIS content, which is a content manager, and we're going to use the search method. We're going to provide a query string. In this case, we're going to search for the United States, and it has to be owned by Esri. We're going to search outside our organization, and we want a hosted feature service layer. So let's see what that looks like. So it's going to go out and query ArcGIS Online and look for our content. And then you can see that it brings back a display with this rich display of the various items that we found based on our query string. And notice that they're all owned by the Esri user, and they have in some relation back to the United States, so US or United States. Now that's a limited search, and it only allows us to get back a maximum of 1,000 items. But let's say you want to do more than that, or you want to get or you want to have full control over your search. So we recently introduced the idea of an advanced search, and it provides you the ability to do custom paging, and you can get your responses back either as a dictionary or an item. And it also has the ability to get back certain statistics. So let's take that same query from above, where we have owner, Esri, and the word United States, and then provide some limitations on the type of information that we get back. In this case, we want to get back feature collections or feature services. So we have our query, and we're going to do the advanced search. But before I get back those results, I want to know the number of results that are going to be returned. So we can see that the maximum is 20. Now, maybe I've already seen the first 10, and I want to use that paging option. So I can pass in my query and tell it to start on the 10th item, and get those same results back, but in a limited subset. So we can see the results coming back. So instead of getting back 20 items, we're only going to get 10 because we started at item 10. And you can see them populating. The next part is we can visualize content. And what we can do here is off the GIS object, we can do gis.map, and then we can put in optional location. When you put in an address, it'll geocode to that location, and it'll display it on the map as in the center location. We can then do things like setting the zoom scale in or out. And now we have a map displayed with the default. There's a whole host of predefined base maps that we can use when using the web map. And here's some what they look like. So we're going to just loop through the various ones. We have dark gray, gray, hybrid. And what this will allow you to do is it'll allow you to see them all visually. And then you can pick the one you want to use for your web map to display your information correctly. Now that we've gone through some of the examples of the types of base maps we can use, I'm just going to go ahead and I'm going to set it to dark gray. You can see our background and the web map change to the dark gray base map. We can then access information to host of feature layers. So I'm using GIScontent.get here because I know the exact item ID for these two items, and I can go ahead and add it to my map. Now that they've added back to the map, you can see the results draw on top of our base map that we selected. We can then go ahead and we can persist that item on our portal by doing m.save and adding in the various properties that we want associated with that item. All right, so now we're going to go back and get into some of the what we're actually here for and start talking about analysis. So for those who come from the background, the desktop background, geoprocessing could be very familiar with you. And for those who don't, all geoprocessing is, it's basically a framework and a set of tools used to process geographic and its related data. And it follows the following workflow. You have a published service out there that ends in GP server, and you consume it. And you can take that and pass in data, and it allows you to perform a task. And then from that, you're going to derive a new product. So think of it as basically your workhorse for doing analysis. And the ArcGIS API for Python can consume these published GP tools. So it just doesn't have to be through desktop. And we can derive those same exact informational products that you would as if you were in ArcGIS Pro. So and then on top of being able to consume generic geoprocessing tasks, we also have in the ArcGIS.features submodule a whole host of analytic tools that we can use to do the same sort of geoprocessing, but they're optimized for the web GIS. And it's going to allow us to basically discover and find patterns within our data and trends. And in very broad categories, we can summarize, we can enrich our data and analyze patterns. So if you analyze patterns, think hotspot. We can do proximity analysis with buffering. And these relationships that we get out will all come out, and they can either be persisted on your enterprise or they can be stored locally. And we're going to see that now, how we can combine these two in a demo right now. So we're going to start right now doing analysis with a generic geoprocessing tool. And it's going to begin with an import. So we're going to have our standard import from ArcGIS.gis, but we're going to do a couple additional ones. And the one we want to focus on here is this one, from ArcGIS.geoprocessing import toolbox. We're going to connect to our GIS, and we're going to find an item that's on ArcGIS Online that's called ViewShed, and it's owned by Esri. But notice the type, it's called the Geoprocessing Toolbox. So we're going to get our item, and it's going to be ViewShed. We're then going to go ahead and we're going to import our tool. The import tool, what it's going to do is it's going to create our toolbox object, and it's going to inject our functions into it. So when we do the dot syntax on that, we're going to be able to access it as if it's a Python method. And a couple other And another interesting thing it does is it'll fully bring in its help. So any help that's published along with the viewshed, that help will also come in along with what the value's name should be. So maximum distance units, you can tell that it's a type string and it's an optional parameter, and the default's kilometers. Knowing that, we can go ahead and we can start building an interactive, we can build, say, an interactive map to do analysis. And what I did here is when you click on the map, this do analysis function is going to go in, use that toolbox that we imported from before and call that method that we injected into the toolbox, take the results and add it back to the map. And we can see that up here. Now we just saw an example of using geoprocessing to consume any type of geoprocessing import toolbox to consume any type of geoprocessing tool. Now we're going to look at how we can take advantage of those ArcGIS.feature analysis tools. And we're going to use the example of looking at political donations because we're in a election year in the United States. So we're going to go ahead and take a look at it. So once again, I'm going to sound like a broken record, but we're going to do from ArcGIS.gis, import GIS, and we're going to connect. In this case, I'm going to authenticate using named user to ArcGIS Online. I'm then going to go use GIS content.get, and I'm going to pull down a voter file that's a CSV file and save it local. And here we have our voter file for this area in Maryland that has the amount donated for each person and if they volunteered or not. We can go ahead and take this non-spatial information and geocode it by doing gis.content.import data and pass in our data frame. And it's going to give us a feature collection back that we can then put on a map and see what it looks like. So we're going to define our area, an extent for a map over Maryland, and we're going to add the feature collection to the map. And what you'll see is points showing up on the screen. We can then, now that we have the locations of where the individual donors or voter files say they are, we can then enhance that by adding additional information and associating it, let's say, with census tract. So maybe we want to know how many people donated within the census tract. So that's the question we want to ask, and maybe we can then, from that information, we can derive an age profile that we want to look at in order to determine who we should target to maximize the most amount of donations. So I'm going to go out and I'm going to get this Maryland census boundaries, and we're going to take a look at it. And what you can see here is that we have we're going to go out, we're going to query our first layer for the area that we want, and we're going to look at it on a map. So it's going to go out, do a where query, pull down all the data, pull down all the polygons, and plot it on the map. So this is what our area looks like. Now we're going to take advantage of some of those summarization tools that we have, and we're going to use from ArcGIS.feature summarize data, import summarize within. We're going to go ahead and we're going to call this function, and we're going to pass in our spatially enabled data frame, and we're going to give it an output name, and along with our geocoded location so we can summarize the donation value within those polygon areas. And we get a result back. We're then going to add that information back to the map once the summarize within takes place. So what we're doing is we've converted our spatially enabled data frame to a feature collection, and then we're sending it to the geoprocessing tool, which will actually convert our results into a hosted feature service layer. So at this point, you could just take these results and reshare it back out with someone else, or we can add it on a map like we're going to be doing in a second. Once we have our areas, what we're going to do is we're going to enrich the information so we can get more age statistical information to develop that age profile that we wanted. We're going to use the geo-enrichment functions that are available, and we're going to grab the age variables that are allowed to us. We're going to take our our new result spatially feature layer that we created with the summary within, and we're going to pull that information down. We're then going to enrich it with the age collection. So we're going to not only have that donation information and the is volunteered information associated with that, with those point locations, we're also going to add the age information. We can then use simple math to find and calculate the dollars per person for that donation. And we can visualize it back on the map to see, and we can use the Esri natural breaks in order to show where we're getting the most bang for a buck for our fundraising opportunity. Once we know that, we can go ahead and we can start calculating age pyramids. So if we look at the total donations as a whole, we can see our population tends to skew to the older range up here on the male side, 55 to 59, but then we also have some spikes on the female side that's between 45 and 49. But if we only want a specific, if we only want to target dollars per person that they raised $4 or more, we can see in the area that we're concerned about, we want to target younger males between 25 and 29, and females around 35 to 39, which is quite different between the two. So that's an example of doing analysis and geoprocessing. So switching from vector data, we're then gonna move over to Raster Analytics. And the ArcGIS.raster module is gonna provide hundreds of raster methods to do both on-the-fly and persistent analysis. These methods range from map algebra to built-in analytics like NVDI, or even custom Python algorithms that you want to pass in to render and manage your data itself. So why don't we go ahead and take a look at the various ways we can take advantage of Raster Analytics. So we're going to go ahead and we're going to connect to our GIS. In this case, we're going to use ArcGIS Online again, and we're going to access some Landsat imagery, and we're going to get the multispectral Landsat data. It comes back as an image layer, and it also gives you the URL when you access layers. One of the neat things about the ArcGIS API for Python is that we can access and display information in rich HTML format. So we can take advantage of the Landsat's description that's in rich HTML and display it so we get a better understanding of the information that we're working with. So we can see it talks about all the different band combinations, what the default is, the available spectrums that we have. And once we understand that, we can go ahead and we can start taking a look at our data. So by default, what you'll see when you display the Landsat layer is you'll see an overview in the default color scheme that's set up for a raster layer. So here we have the full world view of our data set and how it's rendered how it'll be rendered on a map by default. We can access individual pieces of information for any image layer by accessing properties and the key properties. So let's say we want to get the band combinations again, but in a more user-friendly format, in this case, a pandas data frame. And then we can turn around and visualize it on the map. So here we have the Landsat imagery added to a map over top of our base map. And if I pan, you can see that it hasn't rendered, and it only renders what the current extent is for that data set. We can then go ahead and we can look at the various functions that are built in. So raster functions don't have to come with become built in with our data source, but a lot of them do. So let's take a look at some of the raster functions and how they can be applied and how they can be viewed on your map. And what it'll do is it'll go through, it'll apply the function to it for the various types, and then it'll apply it back to the data set, and you can see it scrolling through now. Once you know the raster function that you want to work with, you can go ahead and you can apply it to your data set, and then you can see how the default view changed from what we had before. So here we're using color infrared, and you can see how the map is rendered on the fly versus the original default renderer. We can zoom into an area and add that color infrared that we set for that Landsat layer and add it back to the map. And we can set additional area of interest queries as well. So here we have our Landsat area that sits on a web map, but here we're just going to display like we did before, and we're going to say a color infrared, our extent that we're interested in is the area of Phoenix, Arizona. And when we go to display, instead of giving us that full world view overview, we're going to get it just for the area of interest that we're interested in. And just to compare the two, you can see that the color infrared and memory image looks like the one above, and the default Landsat imagery looks like the one below. And once you know what you want to do, you can go ahead and you can export it. So here we're going to take that default Landsat imagery and we're going to export it out, and we're going to display it as an image on our HTML page. But we can also save it to disk. So if you have an image and you want to save it locally, maybe do for analysis down the road, we're going to put it out to a JPEG, save it locally, and then we can just re-show that we added it back in. You can apply any raster function to export data as well. And you can also go ahead and you can extract custom bands. So if any of the raster functions don't apply with what you're going to do, you can specify the exact band combination that you want. In this case, I want natural color over Phoenix, Arizona, and I can display that area on the map. You can use geometric operations to clip by area. So what we're going to do is we're going to add that clipped area to our map, and you can see we have our clipped area for the imagery on the map. We can, just like you can do with vector data, you can select images by using where clauses and geometries and time ranges. So we're going to use the Sentinel-2 data, which is data that's provided by the European Space Agency to do some of our querying. And we're going to set our extent just like we did before with the Landsat data. And we're going to set it, and we're going to say we want cloud cover less than or equal to 1%. And we want it only to intersect the area of our interest. And this will give us a data frame, and the data frame will tell us the area that's actually covered and how much cloud cover we have in this area, and then some also other information about the various tiles we're pulling down, like when it's acquired and what the tile ID name is. From this query, we actually have 335 images that meet our criteria. Okay. We can then use that information to perform change detection. So we can take the newest image and the oldest image within our query field, and then do a simple diff on bands 3 and 4 and show the result before. And if you're happy with your analysis, you can then take that information, persist it onto your enterprise by doing a diff.save or an image layer.save, and you just give it a name, and now it'll be on your enterprise. Now that's a good overview of some general information that you can do, but let's look at a more focused application. And in this example, what we're going to do is we're going to look at Missouri flooding. And Missouri historically gets some pretty severe flooding over the years, and sometimes it can get over 11 inches of rainfall. So what we're going to do is we're going to use this notebook to perform flood classification, and then that can lead to down the road impact assessment. So the first thing I want to do is I want to show you what the impact is. So on the image on the left, what we have is we have Eureka High School in Eureka, Missouri. And on the left side, you see the pre-flooding, and on the right side, you see the post-flooding. In order to do our analysis, we're going to take advantage of some data that we put onto our enterprise, and we're going to access the pre and post flooding items. So here's our pre and post. So this is what we're doing. We had, instead of using any of the freely available, we actually got flyovers from Digital Globe. Now we're going to go ahead and we're going to train our classifier. And what we're going to do is we're going to read some polygons in from a JSON file that we have for training samples, and we're going to convert it to a feature set. we can go ahead and we can plot it on the map, and you can see what it looks like. So we have these little triangles and slivers, and we're going to use that to help us build our classification scheme and our digital profile. So we're going to do from arcgis.rasters.analytics and import train classifier. We're going to give it the post flooding and those sample points that we had, and then we're going to use SVN, which is support vector machines, and we're going to use this method because it's one of the best off-the-shelf classification schemes for supervised learning, and that's going to give us our classifier definition. Now that we have our classifier definition, we can go through and use the from arcgis.rasters functions. And we're going to classify our post flooding to see how well we did. We pass in that imagery item that we had for before, along with our classifier definition, and we get a result that looks like this, where the areas in blue are our flooding. So we did pretty well at identifying our flooding area. All right, so let's get back to it. So switching from raster, we're going to go back to vector for a bit, and we're going to talk about another way we can do in-memory analysis, and that's the spatially enabled data frame. And the spatially enabled data frame is a unique data structure that we developed, and it's built on top of Pandas, the Pandas Python package. The SEDF allows for basically the consumption of both local and online data. And it's cross-platform, which basically means that it'll work on Linux or Windows or Mac. And it also has multiple geometry engine support. So all that means is that if you're on a Mac and you don't have access to using ArcPy as your geometry engine, you can install Shapely and still have that basic geometry operations like buffer and intersect and things like that. It's really good for interoperability, so you can consume a whole bunch of formats, GeoJSON, our feature services, any format that you can consume in ArcPy as a feature class, you can consume within the spatially enabled data frame, and it also has a robust visualization library. So let's take a look at some demos of doing a spatially enabled data frame. So we're going to start with some basics before we dive into a higher level example or more focused example. So I said before that it's built on top of a Pandas data frame, but the really unique thing about the spatially enabled data frame is that we don't touch any of the underlying architecture of Pandas, because Pandas does what Pandas does best, and we do what we do best, which is spatial. So what we did is we took advantage of the new accessor pattern that the Pandas team has developed. And all that means is on a geo series, we injected a namespace called geom, which stands for geometry, and that does your geometry operations. And on a data frame, we injected a namespace called spatial using the accessor pattern, and this allows you to do wholesale, I guess you would consider it to feature class operations. So let's get started. If you don't want to import anything else but using the spatially enabled data frame, all you have to do is import pandas as PD, and then do from arcgis.features import your geo accessor and geo series accessor. And basically the load operation is that it loads pandas into memory, and then it puts those two namespaces into pandas using the approved pattern by the pandas developers. And then we can go ahead and we can start consuming information. So here all we're going to do is we can consume information from feature layers, we can consume from feature classes, and we can also take existing data frames and make them spatial. So one of the feeds that's out there a lot from the USGS is the earthquake map, and this isn't inherently a non-spatial data set. It has a lat and long column, but it isn't actually spatially enabled. So we can make it spatially enabled by consuming our earthquake data set, passing into the pd.dataframe.spatial from XY, give it the data frame and the columns and the coordinate system that we want, and now we have our spatially enabled data frame. And if we want to do nothing else but consume data, we could go ahead and turn around and persist it right back out. So we can push it out to other items doing gis.import.content.import data, and we can push our information back to a hosted feature service layer on our enterprise, or we can turn around and write it locally to disk. And in this case, we're going to take our data and we're going to write it to a local file geodatabase. The spatially enabled data frame provides a rich collection of tools for visualization, and the data doesn't have to exist on Enterprise to be able to display it. So that means we can take advantage of some in-memory mapping features that we allowed in order for you to see your data before maybe you settle on a renderer. So it allows you to sort of play with your data before you decide to use it. So let's take a look, and what we're going to do is we can go ahead and we're going to pull some data down and show it on a map. So we're going to focus over New York, New York. We're going to set our base map to streets, and we're going to show it on the screen. We're going to consume some data. This is a point data set, and we're just going to add it on the map. So we're not going to do anything special to it. We're just going to show us, plot some points on a map. And here you can see we have a bunch of points. We click on it, we get a pop-up and the information. But going from simple, we can do more advanced. So in this case, what we're doing is we're taking that same exact data set, zooming out, and we're saying instead of giving me circles, we're going to give me diamonds, and we want this color. We want a color ramp to be our reds are, and the 10th step in our color map is going to be our internal color, which is the dark red, and we can set the marker size, and we can be as simple or as complex as you want, and we support a whole host of different types of rendering. So here's in-memory class rake rendering, and then we have continuous rendering as well, and we can take advantage of the various algorithms that we have in the JavaScript API, like classify natural breaks. And moving beyond that, we can even show that you don't just have to render points. It supports all the different types of geometry that we have. So points, lines, polygons, multi-points. And then here's the same exact classification scheme using the natural breaks for here. Now, you're probably wondering, how do I know what these various color maps are? Well, we modeled our plotting API on Matplotlib, and you can get a full list of all the various color maps by doing from ArcGIS.mapping import display color maps. And this function will output a rich display where you can see all the default color maps. And if you don't like any of these, you can also go ahead and just create your own, but they're just there to help you and make life a little easier. Another advantage of using spatially enabled data frame is on-the-fly indexing. And what the indexing is going to do is it's going to allow us to quickly find locations, but they're generalized locations because they're based on a minimum bounding rectangle of your item or feature. So let's look at an example again. And what we're going to do is we're going to use the major cities again. And we're going to go ahead and we're going to query that and return it as a spatially enabled data frame. And then we're going to do sdf.spatial.sindex, and we're going to say, I want to build a quad tree. The other index we could build is an R tree index as well, but in this case, I chose quad tree because it builds quite fast. Once I have that, I'm going to do index.intersect and give it a bounding box. And this is the extent of New Jersey. Now, if we go down and look at our results, you'll notice that some points fall outside of New Jersey. New Jersey isn't perfectly square, so you would have to do an additional query from the other query to sort of parse down our results. That's because our index is only a generalized search. We can also use the spatially enabled data frame to do analytics. So if we take that example that we had before with the viewshed, we can do the same exact thing, pass in our SEDF, perform our analysis, and see what we can see with our viewshed and plot it back on the map. We can also enrich data using spatially enabled data frames. So we can go ahead and we can go ArcGIS.GeoEnrichment, import enrich, pass in any spatially enabled data frame, add in the data collection that we're interested in. In this case, once again, it's age, and we can plot it on the map. So here's an example of South Charleston, West Virginia, and we've enriched the data, and you can see that all that information exists on our spatially enabled data frame. Now let's go ahead and look at how we can use spatially enabled data frames and sort of bring together third-party libraries to help us. So sometimes you need tools that work outside of the ArcGIS ecosystem, and the spatially enabled data frame is a good tool to use to sort of bridge those various worlds. So in this case, our goal is to establish a relationship between ocean measurements and the occurrence of seagrass. And we're going to use a supervised machine learning method called random forest. And random forest is going to help us build multiple decision trees, and we're going to merge them together to help us make a better prediction. For those who don't know, seagrass is very important for the environment and the Earth's surface, because basically you can consider them to be underwater forests, and they're going to provide food and shelter for a wide range of animals. And this includes crabs, turtles, birds, and for their food source, and they're very vital to local economies. And as they disappear, so does the economies and the ecosystem and the wildlife. So in order to prepare our data, we're going to use two libraries. We're going to use scikit-learn, and we're going to use the ArcGIS API for Python. And we're going to start by doing our standard import pandas as PD from ArcGIS.features import feature layer, because we're going to consume a feature layer, and then our GeoAccessor and GeoSeries accessor. We're going to go ahead and consume our data and get it back as a spatially enabled data frame. We're then going to do some, we're going to then go ahead and we're going to do some data wrangling, and we're going to convert our data types from numeric to categorical, and we're going to clean up our data set. Once we have that, we can go ahead and we can do a correlation matrix between our predictors, and we can see what's important. So here we have a matrix where the top half equals the bottom half. The lower the number, a negative number means the negative correlation between 0 and 1. Same as for the red. So the closer to 1, the higher the correlation there. So 2-second overview. So what we're going to do now to create our model, we're going to split our data into training and test data sets. And we're going to use the sklearn.model selection, import train, test, and split. And we're going to split it based on the percentage, 10%, and it's going to give us our data. So our training data size is going to be 10,000, and our test data is going to be 90,000. And we're going to use this to test to see how well our model does. So we're going to go ahead and we're going to create a classifier. So we have our predictor variables and we have our classification variables. Once we know that, we can do from sklearn.ensemble, we're going to import our random forest classifier, and we're going to build it out. We're going to pass in and fit our model based on our training data. So we have our indicator and we have our predictive variables. We can, based on the model that we used, we can see what it says is the variable of importance. So here we see dis02 is the highest variable of importance. Now we can go ahead and we can predict on our test data set how well it does based on the occurrence. So we just do our random forest dot predict, pass in our test data set with our prediction variables, and it gives us our predictions where 0 is false and 1 is that there is seagrass. We can then go ahead and we can calculate the prediction accuracy for our results. And we're going to calculate it. So with our model, with the information we have, we're able to get an accuracy of 99.74%, and we're able to predict quite a high number of seagrass locations. So we did pretty well. So we did many examples of analysis, and now we're going to move on to adding, looking at something else, and that's called Geo-Enrichment. And we've used it throughout our demo, but I want to specifically address it. And you know, you can't really find answers without having data to back it up, and sometimes you just don't have access to it. And Geo-Enrichment provides, especially when it comes to demographic and business data, a place to look for that information. And you can find facts about locations, you can do reporting, and it'll help you discover new insights within your data. And any data you already have published, it'll actually complement your data and build it up. And so let's show you a little demo of how this works, of Geo-Enrichment. So like we said before, Geo-Enrichment provides the ability to get facts about a given location, but it's going to require you to be authenticated because it does cost credits. The neat thing about geo-enrichment is that it covers over about 137 countries. Well, it covers exactly 137 countries. And you can list all the different countries you want out. The first 10 is Albania, Algeria, etc., Australia. And you can filter countries by various properties. So let's say you know the continent that you're interested in, whether it's North America or Africa or Europe. But in this case, I'm going to use Oceania, and that covers the following countries. So now I can parse down and see what information it is based on the location in the world that I want to look at it. So let's go ahead and get some information about Australia. And we can see that I indeed have Australia, and we can look at the data collections. And this comes back as a data frame. And the reason it comes back as a data frame is because it's easy to use and easy to search for information. And for Australia, we have over 1,966 data sets that we get back for Australia. And it does vary from state to country to country, the type of data, the amount of data you have. I believe the United States has like 13,000 or something like that. So, and we can drill down further and deeper into our data collection and look at the various analysis variables that are available based on the area of interest in this. So in this case, I'm interested in educational attainment, and I want to see the various variables that actually reside within that educational attainment. And here we just have, you can also display it here. So you, because these codes aren't always helpful, so you also gain information from the aliases to help you figure out what your collection is. Once you know what you want, so you can go ahead and you can enrich your data. So in this case, I'm going to geocode the location of Parliament in Canberra, Australia. That's the capital. And we're going to plot the data. And what you see is from that location, it buffered it out a mile, which is the default. And you get the various educational attainment for that area. From this information, you could go ahead and you could generate reports. So let's say I'm interested in, for the exact same area, I want to know the average food spending for that area. So you can run create reports and it'll return back a PDF. And we can go ahead and we can take a look at that PDF here, and it's going to give a lot of information about the area. And one thing you notice is that it's all back in the currency of the country. So it doesn't adjust everything to be US dollars. It stays within the area that you're looking at. And the same thing applies when it comes to named statistical areas. So for the United States, if we look at the geographies of the country of the United States, it goes states and then counties, and then we have tracts, and it goes farther down, and it always stays that nomenclature. But if we were to turn it around and use a different country, let's say India, it would still go India and then states, but then instead of going counties, they go districts, and it persists that nomenclature for the state throughout. So you don't have to adjust to the syntax that we think's right. You can stay with the country that you're interested in and use that nomenclature. Okay, so that's a little bit about geo-enrichment. Next, we're going to talk about two very important parts, and the first one is network analysis. And the NA, or network analysis, is going to solve those point A to point B problems and the routing and the service areas. And it's in the ArcGIS.networks module, and there's a whole host of tools of doing that. And then on top of that, we have geocoding, and this is, it either supports single or multi-line geocoding along with batch and reverse geocoding. This exists in the ArcGIS.geocoding module. So let's take a look at a demo of doing that. So network analysis is basically going to allow us to solve those common network problems. And some of the examples of doing this is finding the best route from getting across the city, closest emergency management facility for a, closest emergency vehicle to a facility, things like that. And in order to do that, we start by connecting to our GIS like we did before. So from ArcGIS.gis, import GIS, we're going to give it a profile. You can see I'm me, so that's great. And we're going to go ahead and we're going to do from ArcGIS.network, import service area layer. where then, because I'm authenticated, I can go ahead and I'm going to access my URL for my service area analysis, and I can go ahead and I can consume that and instantiate my service area layer. I can then go ahead and I'm gonna geocode a location and display it on the map. So what I did here on this map right here is I took a point, drew it on the map, and I found how far somebody could travel on given time. And let's see how we did that. So before knowing how I want to travel, I first need to figure out the method I was going to travel, and I needed to look at the various travel modes that I had. So I can go and print out and see that the service area supports a whole bunch of different methods, from walk time to rural drive time. But I'm interested in truck time, so we're going to do that, and we're going to get the truck mode. We're then going to use the solve service area to do that with our default time breaks of 5, 10, and 15, and then plot it back in the map, and this is what we get. On top of that, on top of doing that type of service area analysis, we can also use it for basic routing. And once again, because I'm authenticated, we're going to leverage the service that's registered with our ArcGIS Online enterprise, and we're going to use this URL to create a route layer. We have our stops. So our first stop, our entry 1 is where we're going to start, and entry 2 is where we're going to stop. We're going to use the batch geocoding in order to assign a XY location for those points, and they come back essentially like this. We're going to do a little data wrangling, and then get our driving directions. So we're going to do route.service.solve, pass in our 2 geocoding locations. We want to return the routes and our driving directions, and we're going to go ahead and display it on a map. So now we can visually see how to get from point A to point B. But on top of that, we can also visualize our driving directions. Part of the return result gives us our driving directions, and we're going to return that as a list, put it into a data frame, and then display it on the map. So that's pretty much where to go to. Here's the next thing. So please take a look at all the links, and Amy, I'm ready for questions.
Thank you, Andrew. We're now going to begin answering the questions submitted during today's presentation. We've received quite a few, and we will try to get through as many as possible, but whatever we do not get to today, we will address in a GeoNet blog post after the webinar. As a reminder, you can still submit questions through the questions pane in your attendee control panel. Our first question is, can the Python API be used to replace a web map's base map with another base map?
Yeah, so you can do that by editing the web map JSON underneath right now, if you don't want to use one of the pre-canned web maps that you saw before with replacing a base map.
Great. Is the ArcGIS API for Python just for ArcGIS Online and ArcGIS Enterprise Portal, or can it be used to connect to ArcGIS server services directly?
You can connect to ArcGIS servers directly using it's called Service Directory class. And it works just like you would with a GIS class, where you pass in your username, password, and URL, etc.
All right, thank you. Does the geoprocessing connection to ArcGIS Online consume credits?
Do you mean if you're consuming a publicly shared geoprocessing service that's out there, there's no credit consumption. If you're using some of the tools that act semi like a geoprocessing tool, there could be credit consumption, and you just have to consult the help on whether it does that or not.
Great. Is the ArcGIS API for Python available with ArcGIS Pro 2.4?
So the ArcGIS API for Python comes with Pro installed, and it's come in the last 2 releases, I believe. So it's been there for quite some time.
What would be some common use cases for using a notebook rather than writing Python scripts in desktop or online?
So notebooks are all notebooks are versus a regular traditional IDE is a web-based IDE that executes Python code in the same exact way. So if you were doing reproducible workflows and you wanted to document your code in rich HTML and text, it's a good way of doing it. If you're doing traditional development and let's say writing an API, I wouldn't start by using Jupyter. I would use something more traditional like PyCharm or Wing, something like that.
All right. During the Landsat imagery demo, when you said image layers, do you mean ArcGIS image server or just a general raster image layers?
I mean, it can be either or.
Okay.
But published raster layer.
Okay. Where can I find more information about credit usage when doing analysis online through scripting or in a notebook? Meaning, will the credits consumed appear somewhere like it does when I'm using those tools in the ArcGIS.com map viewer?
Yeah, so the in the ArcGIS.features module, I didn't show this because I had a lot to show, but there is an estimate parameter, and you can pass that in, and it won't execute the tool, but it'll tell you how many credits you're going to consume.
Does the API give us the ability to control imagery transparency settings so that we can better see more than one image at a time?
That's a good question. That would be a render property, so you could go in and manually provide any rendering information you want on like for vector data, and yeah, you could make you could set the alpha level or the transparency. Yes.
In what ways does Esri provide open data or data that is shared that we can analyze and visualize?
We have the hub, the Open Data Hub that you can go online, and it's a community-based area where people share information. And on top of that, we have Living Atlas and general ArcGIS Online information that's shared. Those are two great areas of finding open data information.
Great. Does the search use the content tags given to services when they are built, or is it searching using some other methodology?
So with item searching, if you can a general query, so like I was searching for United States, it's going to go, I believe it goes through the title first, and then it'll eventually fall down to the other items. But you can specify tags specifically if you were looking for something specific. I believe it's tag colon, and then it's a double quotes, the value, close quotes. Yeah.
All right. It's pretty neat that the maps and graphics displayed in the notebook are live and interactive, but how can I export those as images like JPEG or PNGs?
There is so if you want to export a web map, there is a function on the map that allows you to export that map to an image. The name of the method eludes me at this moment, but it's there at the latest version. In previous versions, it isn't. So.
Okay. What are some ways we as GIS professionals can use this API for making data analysis and those results more accessible to non-GIS pros, say, without using Jupyter?
Yeah, so one thing you can do is you could take your workflows that you have, and one, if you do it in a notebook, you can create your web map and then share that web map out as a to other users so they can see the information, the results, if they don't care about the workflow. You can also export Jupyter notebooks to HTML files and make them static pages. And then you could take that information and host it on a website that anybody could go to. Those are just two ways. If there's anything else that I missed, please let me know.
All right. And for our last question, is the Python API standard with a basic subscription?
Is it standard? It's free to download and free to use. If so, I would say yes. I'm sorry, I don't know the complete answer to that.
All right. A number of people have asked if you'd be willing to share your presentation. If so, we can put it in the blog post on GeoNet. Is that possible, Andrew?
Yeah, I'm also on the third link from the top on the where to go from here on the GitHub page. So github.com/esri/arcgis-python.api. We put all our talks there. So not just the one that you're seeing today, all the previous talks that we've done either at UC or UC or Dev Summit and other webinars we've done. They're pretty much all there if we're allowed to put them up.
Yep. All right. Thank you, Andrew, and thank you, everyone, for attending today's webinar, Performing Analysis with the ArcGIS API for Python. If you have any other questions, please feel free to contact me using my email address that's located in your follow-up email. Once you leave today's webinar, you will receive a survey on this presentation, and we would appreciate it if you would complete that and provide your feedback. We will be providing a recording of this presentation. It will be available within 7 to 10 business days on the go.esri.com/geodev page. On behalf of Esri and our presenter, thank you so much for joining us today, and have a great rest of your day.